So go online and send you a link. Share it with the shopman. Okay, so good afternoon, everyone. Let's just wait for more people to view, then we can start our tutorial. Hello? Okay, so for today, we're going to revise the test. And from the observation, I've been marking your papers. People were just making small mistakes over the test. So we're going to revise the test. I'm sure most of you have your question papers. Yeah. So question one. Question one was asking us to simply multiply and divide. And I taught this in class. To say if we are multiplying and dividing numbers, we have rules that we follow. We just don't multiply and divide. Okay, so the first question was asking us in the first question we were given, that was A1, 2456 multiplied by 0.0123 divided by 5223 times 60.7 multiplied by 8.51. Okay, so that's how we're supposed to arrange the numbers. Is it visible enough for everyone to see? That's how we were supposed to arrange the numbers. So from here, we simply punch those values on the calculator, which becomes, if you punch those values, it was giving you something like 4.64 times 10 to the power negative 8. So I don't know why people were making the mistake here. All you were supposed to do was to divide. Some people were saying, no, you use board mass. But if we were to introduce board mass, it was going to be the same thing. It was going to be the same thing. All you were supposed to do. Okay. I hope it's visible enough for everyone to see. Then the second question was a bit similar, but this time we're adding. So even for this one, addition. And before we even go to the second question, remember when we are dividing numbers, we follow the rule of significant figures. And the one with the least significant figures there was 60.7. So our final answer must have 3 significant figures, which is 4.64 times 10 to the power minus 8. Then coming to the second question, which was just addition. I don't know where people were making a mistake here. We're just going to add the numbers. 1.4167 grams plus 100.5 grams and plus 7.12 grams. So now we're just adding. What was simply supposed to be done was addition. Okay, so at this point, we're just supposed to add. Some people are saying it's not visible. I'll try to increase the font. So on the second one, we're just supposed to add the 3 numbers given. So we have the first number, which is 1.4167 plus 100.5 plus 7.1. So we're just supposed to add these numbers direct. And after adding the numbers, it was giving something like, if you add, it will give you a 109.036 grams. So some people were rounding off, but it was still fine. But remember, when it comes to the rules of addition, when we're adding, we follow the one with the least decimal places. So there the answer was just supposed to be 109.0 grams. Okay. Then coming to the third question. The third question was simply asking us to divide. So the third question was asking us to divide. We were given 2,360 grams over 0.00071. So for this third question, part A, question 1, I don't think there was anything complicated about this question because you are simply supposed to divide the numbers directly, which would give, if we divide 2360 divided by 0.00071, it was going to give us 3. It was going to give us, if we are to round it off, actually before, okay, let me write, it was going to give us 3.3 times 10 to the power 6. That was the number it was going to give us. So for these first questions, there were just 3 marks. You get 1 mark for each. Maybe the second question, the part B was a bit complicated, but I think there was nothing complicated on part B as well. So coming to part B of the question, multiply the following numbers by 372 and express scientific notation. So the first part, we're given 642.2. Then we're multiplying it by 372. We're just multiplying the 2 numbers. So it was going to be 642.2 multiplied by 372, which was going to give us 23898.4. That was our final answer. But remember, the question is asking us to convert this answer to what? Scientific notation. So converting it to scientific notation simply means moving the decimal point to the left. And if you move the decimal point to the left, take note of the power. This was the mistake people were making. It becomes 23.4 times 10 to the power times 10 to the power 6. The decimal point has moved 6 times. So most people were making a mistake in writing -6. You were losing marks for that. It was just supposed to be 2.4 times 10 to the power 6. That was similar for question B as well. We're just supposed to multiply that number by 372 and then express the final answer to scientific notation. Then coming to C. Okay, so coming to C. Let's see. C was asking us to find calculate the percentage error. So to calculate the percentage error, I was given marks for the formula. It was true value minus expected value over expected value times 100%. Okay, so I think okay, so I think I just okay, so for this one, it was average of the expected hello? Hello? Yes. I've sent the link to all the reps. Yes, so tell the rep to share the link with you. Did you what? Okay, so just okay. Okay, so people are saying they can't see. I'll try to make the font a bit bigger, but I think it's just the camera. So I was saying on C, question 1C, the question was asking us to calculate the percentage error. And for the percentage error, it was carrying 5 marks. So the first mark was going on the formula. Okay, so the percentage error. I hope it's visible enough. So for the percentage error, I was given 1 mark for the formula. So it becomes average accepted average of the expected minus accepted over accepted times 100%. So this formula alone was carrying 1 mark. Then what you simply had to do was now calculate the average. So to calculate the average, most people were doing this. The average of the expected was, you simply add the 8.9 mils by 8.0 mils. You add all the 3 volumes given, and then divide it by 3. Then divide it by 3 to find our average of the expected. Remember, we are finding the percentage error, and to find the percentage error, the formula is given there. So you find the average expected minus the accepted over the accepted times 100. And then don't forget that the value on top is an absolute. So even if it's negative, we're going to take it as positive because it's an absolute. So when you divide everything, it was going to give you 8.47. 8.47 mils. Then from here, you simply substitute. We now put our 8.47 mils minus the accepted, which was 10. Because the true value was 10 over 10 multiplied by 100%. Okay, so I'll answer your questions at the end. For those that have any questions, I'll answer them towards the end. So from here, you just substitute. When you subtract this, remember, like I said, absolute means our final answer becomes a positive. So once you substitute here, our final answer was supposed to be 15.3% as our percentage error. I don't know why people were making a mistake on this question. Okay. Then coming to question 2. We're simply converting Fahrenheit to Kelvin. Okay, so let me just send the link to okay. So for question 2, we're simply supposed to convert the following temperatures to Kelvin. So we're supposed to move from Fahrenheit to Kelvin. We know we can't move from Fahrenheit to Kelvin first. We're supposed to first convert it to degrees Celsius. And we know to say the formula is degrees Celsius is equal to 1.8. Okay, so we're supposed to simply do that. Fahrenheit minus 32 over 1.8. We've already been given our Fahrenheit as what? We just substitute negative 220 minus 32 over, we divide by 1.8 there. That is our temperature in degrees Celsius. So when we divide, our final value was coming to negative 140 degrees Celsius. So that is the final answer in degrees Celsius. Then from here, remember the question is asking us to convert it to Kelvin. Okay, so hello? Hello? Just text me. Okay, so when we have our answer in degrees Celsius, we then convert it to Kelvin. We then convert our final answer to Kelvin. So when we take our final answer to Kelvin, we know the formula to say Kelvin is equal to degrees Celsius plus 273. So you just add the two. You put the negative 140 on top. Then we come to percentage abundance. I thought I had mentioned this formula during the tutorial. I don't know why most people were making mistakes when it came to percentage abundance, which is question 2b. So for question 2b, we're just supposed to replace. We're supposed to start by writing the formula for percentage abundance, which becomes, calculate the atomic mass of copper, sorry. So relative atomic mass is equals to, we simply multiply the mass we've been given by its percentage abundance plus the mass of the second by its percentage abundance divided by 100%. So that's what we're supposed to do. Okay, so there are some teachers that are yet, we are receiving the link. I hope we've all managed to join. I'll send the solutions for those that are behind. Okay, so this was how we were supposed to solve this question. You just multiply, then divide by 100%. So from here, we just substitute for the first one, which was 63. Simply multiply the 63 by the 69.17 plus the mass of the second copper atom, which was multiplied by the mass of the second atom and the mass of the second copper atom second copper isotope, by its percentage abundance. Then divide it by 100%. Let me just write it. Okay, so from here we're simply supposed to multiply them. 62 simply supposed to multiply the 62.9296 multiplied by 69.17, then plus the second atom, which is 64.9278 multiplied by 30.83. Okay, so we're supposed to multiply. Then the final answer was supposed to be divided by 100. So I don't know where people were making mistakes. The question is given to you just like that. Don't round off before the final answer. That's where most people were losing marks. So if you round off before the final answer, you discover that your value will be slightly different from the final answer, which makes you lose marks. So from here, what you are supposed to do, okay, so just a minute. Hello? 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 Oh, okay. Which teacher is this again? Okay, let me resend the link. Okay. So from here, we're just supposed to divide the answers. Divide. So if you divide, you find that your answer was coming to 63.55. 63.55. Remember, relative atomic mass has no units. So you don't have to indicate any units. And then coming to the next question. Question C. This question, I think it was in your assignments. Calculate the empirical formula. I mentioned we had a similar question in the assignment. If you're not mistaken, you've not forgotten, sorry. We had a similar question in the assignment. So we have a compound, a compound containing carbon, hydrogen, and oxygen. I had explained this question clearly in all TGs. So I didn't expect people to fail. I tried my level best. I made sure people had gone through. People were asking questions. I asked any questions, everyone was clear. You were all answering, no matter. All we have to do is go through. So a compound containing carbon, hydrogen, and oxygen burns completely in oxygen. So we are oxygen. So if the compound burns in oxygen, meaning our equation is going to contain. So if the compound contains carbon, hydrogen, and oxygen and burns completely in oxygen, to give us carbon dioxide and water. But then the question further says, we've been given the masses of carbon dioxide and water produced. So the mass of water produced is 1.199 grams. And the mass of carbon dioxide produced is 2.197 grams. But the question is asking us to calculate the empirical formula. We can't calculate the empirical formula before we calculate the number of moles of each element. And to calculate the number of moles of each element will first require us to first calculate the mass of each element. So to calculate the mass of carbon in carbon dioxide, I had mentioned this. To calculate the mass of carbon in carbon dioxide, we simply see molar mass of carbon over molar mass of carbon dioxide times the total mass, which is 2.197 grams. Remember, we have to work with what we have. We have carbon dioxide. We want to calculate the mass of carbon in carbon dioxide. And the mass of carbon in carbon dioxide will simply imply that we have the mass of carbon in the element. Remember, this element on the reactant side, it's only containing carbon. So the mass of the reactant is equal to the mass of the product. So here, we then divide. Molar mass of carbon is 4 over the molar mass of oxygen, which is 16 times 2, plus 12, which will give us 44, multiplied by the total mass of carbon dioxide, 197 grams. So if we multiply that, it's going to give us a 0.599 grams. That is the mass of carbon in that element. Then we can now calculate the mass of hydrogen. So to calculate the mass of hydrogen, it's going to be the same procedure. Mass of hydrogen is going to be, this was another mistake people were making. It's not H, it's H2. So it's going to be H2 over H2O times the total mass given, which is 1.199 grams. So that becomes, if we have H2 there, it becomes 2.00 over water, which is 18 times 1.199 grams. So if we multiply 2 divided by 18 times 1.99, the final answer was giving us a 0.133 grams. 0.133 grams. Okay, so we have the mass of carbon. We also have the mass of hydrogen. Then we are now calculating the mass of oxygen. Remember, we want the mass of oxygen in what? In the starting compound. In the compound that we don't know. We don't want the mass of oxygen on the reactants. We want the mass of oxygen on the starting compound. So remember, the starting compound had a total mass of 1.00 grams. And we know to say this 1.00 grams was the total mass of that. But then we only want the mass of oxygen. So we're going to say mass of oxygen will be equal to 1.00 grams minus, we have the mass of carbon, we also have the mass of hydrogen. So the remaining mass is for oxygen. So we're going to simply add the two. We're going to say 0.599 grams plus 0.133 grams. So when we subtract, our final answer was coming to 0.268 grams. That's if we subtract and add the two masses. So we now have the masses of each element. Us having the mass of each element means we can calculate its number of moles. We can now calculate the number of moles to give us the empirical formula. So to calculate the number of moles, we then start with carbon. So we can simply say carbon on top, hydrogen, and oxygen. So for carbon, carbon is having a mass of 0.599 grams. And then the mass of hydrogen is 0.133 grams. And the mass of oxygen is 0.268 grams. So we have their masses. We now calculate their number of moles. So number of moles is simply dividing their masses by their molar masses. So for carbon is 12, for hydrogen 5 by 1, and for oxygen it's 0.268 grams divided by 16. So when we do our divisions, it will be 0.0499, and then it will be 0.133 grams, and then the other side it becomes 0.0168 grams. So when we reach this stage, we simply divide by the lowest, which is 0.0168 grams, and then 0.0168 grams, and the other side, which is 0.0168 grams. Okay, so when we divide everything, we'll find that our mole ratio will be 3. Our values will be 3 for carbon, and for hydrogen to be 8, and for oxygen to be 1. So our empirical formula simply becomes C3H8O1. That's our empirical formula. Then the question further asks us to find the molecular formula, and we've been given the molar mass. So to calculate the molecular formula, I have mentioned in class. So we are supposed to find the n value, the n factor. So it becomes molar mass over empirical formula mass. And the molar mass is the one which was given in the question. The empirical formula mass was the one we're going to calculate after we add everything. So we're going to multiply 12 times 3 plus hydrogen plus oxygen. And then it was going to give us 120 grams per mole. That was the molar mass over 60, which was the empirical formula mass, grams per mole. And our final answer was going to be 2. So our value for n was 2. Simply multiply. We'll get our C3H8O1 multiplied by the n. But our n was 2. So it becomes C6H16O6. So our final answer. Okay, so for today we've done question 1 and 2. I'll inform you when we can proceed with question 3 in section B. So our tutorial is going to end here. Let me try to answer some questions that people were asking. Okay, so most people are saying they can't see anything, but I'm sure I'll send the solutions probably today to all your classrooms so that you can go through. And if you have any questions, you are free to call and ask. I'll answer your questions. So we can end here for today. Thank you.